Okay guys, today we are going to be discussing inverse functions, and we've talked about some of this already, and basically what we're going to do is work with one of these graphs of sine or cosine, such as the one shown, and there are going to be three things asked that are asked of you. First, to solve it for x. Okay, if you had a word problem involving this cosine function, you could plug in x's all day long and find the y's that go with them. Basically what we're doing here is we're trying to find x's that go with a given y value. So we're going to isolate x so that we're able to more conveniently plug y in. And we're basically just going to get all of the algebra steps out of the way and get it kind of a nice formula for x. The next thing is going to be to find the first three positive values of x for y equals 5. Meaning we're going to plug in y equals 5 and figure out some of the values of x. And as you'll notice, or as you will see soon, there's going to be infinitely many times when y equals 5. You can just imagine, you don't need to draw this, but imagine this cosine graph that's been moved up 6 with an amplitude of 2. It's going to be crossing the horizontal line y equals 5 several times. We're just going to find the first three positive ones, so something like those three values, and that we will get to eventually. We're going to solve it analytically first, and then we're going to graph to confirm. And show that those three values make sense on a picture. So let's start with A. We'll just get a nice new color here, this guy here, and let's solve this thing for x. So I'm just going to rewrite the original, and then just do some algebraic steps to get x by itself. So I'm going to start by subtracting 6 from both sides. And what's going to be left on the right is 2 cosine of the fourth, on and on. I'm going to go ahead and divide by that 2, just to speed up the process a little bit. Once you get the hang of this, you'll probably be able to do it all in 1 or 2 steps, but let's not cut out too much just yet. So what I did do was subtracted 6 and divided by 2. The next thing I have is one big cosine on the right. So the opposite of cosine is inverse cosine, or arc cosine. Either way that you want to write it is fine. So I'm going to arc cosine both sides, because when you inverse cosine the cosine of 1/4 x minus 3 pi, you're left with 1/4 x minus 3 pi. You know, just like in Algebra 1, when you had x minus 2 equals 4, you chose to add 2 to both sides because the operation that undoes subtraction is addition. Same thing here. The operation that undoes cosine is cosine inverse. So we're going to cosine inverse both sides. Alright, so here we are, still trying to isolate x. The next thing I want to do is either divide by 1/4, but technically that's just multiplying by 4. So I'm going to do 4 cosine inverse y minus 6 over 2 equals x minus 3 pi. And my final step is to add 3 pi to both sides. So just by undoing each step, some nice old-fashioned Algebra 1, we have isolated x, and this is our answer to part A. Fair enough? Okay, so now we're going to plug in 5 and see what we get. This one will look good in orange. So, x equals, to part B, 3 pi plus 4 inverse cosine of 5 minus 6 over 2. Some of these are going to be answers that you find using your nice, neat unit circle points, and some of these are going to be answers that you find in your calculator. We'll just have to see what we get when the time comes. So Let's break it down as much as we can. This inverse cosine, remember, is going to lead to infinitely many answers. We're just looking for the first three positive ones. So we'll get a list of all those answers and then just select the smallest three positive. All right, so that's -1/2. And now this is a point where we're either calculator or unit circle. We might start unit circle and end up calculator, but the point is this expression, cosine inverse of -1/2, has infinitely many answers. We are asking, cosine is our x value, where does that equal -1/2? And that's going to happen up here and down here. And since this is a radians question, let's do this in radians. We have 2 pi over 3, and we have -2 pi over 3, or we could call that one 4 pi over 3, either one. So, at this point we're going to have to break it down. This expression, cosine inverse of -1/2, one suitable substitution is 2 pi over 3 plus 2 pi n. That's going to take care of this angle here and as many repetitions around the circle added onto that angle in both directions that we want. Okay, the other one, I'm going to erase my circle so I can put my or, because my other possibility is 4 pi over 3. Just do the whole thing over again. You could have called that one -2 pi over 3 if you wanted to, instead of 4 pi over 3, but either way you're going to cover the infinitely many different possibilities. So you're fine either way. So now we just need to do the rest of our algebra to try to figure out what x is. So let's distribute the 4. 4 times 2 pi over 3 is 8 pi over 3. And 4 times 2 pi n is 8 pi n. Then put together what you can. 3 pi plus 8 pi over 3 is, let's see, 3 is 9 pi over 3. So 9 pi over 3 plus 8 pi over 3 is 17 pi over 3 plus 8 pi n. And then on our other side, we get 3 pi plus 16 pi over 3 plus 8 pi n. You don't want to do like terms with the one with the n in it, because that n makes it not a like term. But this 3 pi, which is 9 pi over 3, added to the 16 pi over 3 would be 25 pi over 3. Alright, let's put those two together over here just the same way I did over here. And now I just need to start figuring out what my smallest possible positive answers are. Okay, what if on this one we did, let's see, we have 17 pi over 3, which might be easier if that 17/3 were a decimal. That's 5 2/3 plus 8 pi n. So if n is 0, I get 5 2/3 pi. If n is -1 and I try to subtract 8 pi one time, I'm going to go into the negatives. So that's no good. This is for n equals 0. When n is 2, or excuse me, when n is 1, I'm going to take 5 2/3 and I'm going to add 8 to that. So that's going to be 13 2/3 pi, where n is 1. And now if I'm only looking for the first 3 positive values, I'm probably not going to use any more than this. But my next one will be 8 pi more than that, which would be 21 2/3 pi, for n is 2. And I could keep listing those forever, but I know I'm not looking for anything but my first 3 positive ones. So what about over here? 25 pi over 3, that's actually 8 1/3. 24/3 is 8. So that's 8 1/3 pi. That's 8 pi n. So here I could actually let n be -1. If n is -1, then I get 8 1/3 minus 8, which is 1/3 pi. And then I add 8 onto that. When n is 0, I get 8 1/3 pi. When n is 1, I get 16 1/3 pi. And that goes on. And I just need the 3 smallest ones. So this one is definitely my smallest possible positive value, then 5 2/3 pi, then 8 1/3 pi. So my 3 answers should be pi over 3. At this point I'm going to turn them back into not mixed numbers. 5 2/3 pi is 17 pi over 3, and 8 1/3 pi is 25 pi over 3. So those are the 3 first positive values that y is going to have a height of 5. And sometimes with a graph, it might help us to have the decimals of these values. So let me list those two, just in case it helps with our graph. This one is 1.047, and the next one is 17.802, and the next one's 26.180. So we'll check and see, because part C is to draw a graph of this and to confirm. I'm going to pause for a moment and get some of this graph drawn to keep this video length down, and I'll be right back with you. Okay, so here's the picture. Taking the original equation, and part C is to graph it to confirm that our 3 answers are reasonable. This particular sinusoid is a cosine graph with 4 changes. It goes up 6, amplitude of 2, period 8 pi, and it's been moved right 3 pi. So here's that graph. You can pause for a moment and just sketch it. It doesn't need to be great. But let's look and see that it is at a height of 5 where we claimed it would be. Actually, these answers in terms of our improper fractions are going to be the easiest ones to tell. Here, here, here. These are going to be the easiest ones to spot on the graph. They're all the same thing, but we've got 1/3 of pi. So here's 1/3 of pi, and it makes sense on the graph. It's not a perfect spot, but it's very close to the axis. Our next spot was 5 2/3 pi. So 4, 5 2/3, that one's actually pretty right on. 5 2/3 would be about there. 1/3 would be about there. And our other one was 8 1/3 pi. So here's 7 and 8. 8 1/3 without too much off target there. It matches. So we have done all 3 steps. We have isolated y, and we isolated x in part A by just doing our undoing each of the steps, the transformations that had been made to get x by itself. We plugged in 5 and solved, and this is the part that takes a little bit of thought. When you're breaking down this expression, and there are 2 possibilities, you need to go 2 paths, this way and this way, in order to get all your possible answers. We chose the 3 smallest positive ones in the graph to confirm. All right, so there's this section. That's all they're going to ask you to do in this section. These are going to be important to be able to do for when we do more word problems. The word problems you've done to this point, all you could do was plug in x's. Now you're going to be able to plug in x's and y's. So that's 1310. Young's out.